This is our first pre-assessment for the year 2022, 2023. This is a pre-algebra review. First couple of problems are addition, subtraction of integers, positive and negative numbers. So the first thing we always want to do is we want to combine double signs. So when we see a double sign and there's no number in between those signs, we're going to combine them. So two negatives make a positive. And we're not going to rewrite any of those signs. We're going to combine those two signs to make one sign. So we would not rewrite any sign that we see, and we would put whatever sign that makes. And then we have 2 plus 2 is 4. Question number 2, again, we have double signs. We're going to combine a positive and a negative, which is a negative. So we just rewrite the sign that those two double signs make. 1 minus 6, we have a positive 1 and a negative 6, which makes negative 5. Our third problem, we again have double signs. We have a positive and a negative, which makes a negative. The two numbers here are negative 8 and negative 7. When we have two negatives, that makes a bigger negative. So negative 8 and negative 7, I go back 8 paces, I go back 7 more. That makes negative 15. Double signs, let's combine them. This becomes negative 7, 8, and negative 7 plus 8. The two numbers are negative 7 and positive 8. The signs are different. We have a negative 7 and a positive 8. We have more positives, so we're going to end up with a positive number. For the 7 negatives, we're going to cancel out 7 of those 8 positives. So we would be left over with 1 positive. Here we have 3 numbers that are being combined, and we've got multiple doubles. So we're going to rewrite it first. The negative and the positive make a negative, and the negative and the negative make a positive. 8 minus 7 gives me 1, plus 7 is 8. Here we don't have any double signs, so we're just going to take the first two integers. 3 and positive 2 makes 5. Bring down the negative 1. 5 minus 1 is 4. In problem number 7, however, we go back to multiple double signs. So we'll need to rewrite this expression. And now we're going to do the first two. We have 6 minus 2. That's a positive 6 and a negative 2, which makes a positive 4. Then we have 4 minus 7. We have a positive 4 and a negative 7. We have more negatives than positives. So the 4 positives will cancel out with 4 of the 7 negatives, which leaves me with negative 3. Last problem with addition and subtraction, we again have double signs. So this gives me negative 2 minus 7 plus 2. We'll do it left to right because we have addition and subtraction here. We have negative 2 minus 7. So the two numbers are negative 2 and negative 7, which makes negative 9. Plus 2 is negative 7. It's important for us to read what the directions are. What are we asked to be doing? Find each product. That's typically a good little helpful hint. So we're going to multiply. Since everything is multiplication, we'll go left to right, and we will multiply the first two integers. Negative 3 times positive 4 is negative 12. Remember, we're multiplying, not adding and subtracting. And then negative 12 times negative 3 gives me positive 36. We're not combining double signs because we don't have signs next to each other. Much like we would in question number 8, you see the double signs with no numbers in between them. Here we just have numbers and nothing in between, so we're talking about multiplication. So we will multiply those two integers. Negative 2 times negative 5 is positive 10, times negative 9 is negative 90. And our third example in multiplication, we again are going to multiply the first two terms because everything is multiplication across left to right. Negative 2 times negative 5 is positive 10, times negative 5 is negative 50. Last problem for the multiplication, we have 9 times negative 3, which is negative 27 times negative 3. So we can look at this in the sense of, let's deal with the signs first if you want. You have a negative times a negative, so you know your answer is going to be positive. And then we can multiply 27 times 3. If you don't know what that is in your head, which I can understand, go off to the side. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 81. So we will get a positive 81. Write your scratch work off to the side, not in the middle of the work that you're making on the left. Next one is division. We have a negative divided by a positive, so we know we're going to get a negative. And then we take the numbers. 60 divided by 10 is 6. That's the easiest way to tackle these problems. We have a positive divided by a negative, which is negative, and 0 divided by negative 9. 0 divided by 9 is 0. We would never write positive 0 or negative 0 as our answer. Now we may write negative 0 or positive 0 as we simplify through an expression, but for our final answer, 0 will not have a sign, because 0 is neither positive nor negative. Number 15, we have a negative divided by a negative, which is a positive, and then we have 18 divided by 6, which is 3. So we get positive 3. Number 16, we have a negative divided by a positive, which will give me a negative, and then we deal with the numbers. 15 divided by 3 is 5. The next section deals with fractions. The first couple of fractions are going to have common denominators. We love that. When we have common denominators, we can just combine their numerators. Now we look at the numerators, we've got a bunch of double signs. So we want to get rid of those double signs. So we'll rewrite this problem 4/7 plus 5/7. Like denominators, let's combine their numerators. 4 plus 5 gives me 9/7. This is in an improper fraction, but it's okay as our solution because it is simplified. No number goes into 9 and 7. So 9/7 cannot be simplified. It cannot be reduced. If we turned it into a mixed number, 1 and 2/7, that would not be simplifying. That would be called converting. We don't need to convert to a mixed number. An improper fraction is an acceptable answer. Again, we have these double signs. Let's rewrite it. -1/2 minus 3/2. We like this because we have like denominators. When we have like denominators, we can combine their numerators. -1 minus 3. We have a -1 and a -3, which makes -4/2. The denominator just moves across. In addition and subtraction, we have -4/2. We must reduce this. The only answer that is acceptable here is -2. So -4/2 can be simplified to 2. That is not converting, that is simplifying. We have double signs again. Let's rewrite the starting problem before we do any simplification. We like the fact that we have like denominators. We will combine their numerators, and that leaves me with 12/8. Now, 8 doesn't go into 12, but we can reduce this fraction because there is a number that goes into 12 and 8. 4. 4 goes into 12 times, goes into 12 3 times, 4 goes into 8 2 times, and we would leave it as 3/2. You must reduce 12/8 completely. We have 1, 6. We have no double signs, so we can just see that we have like denominators. We will combine their numerators, and that equals 0, 6. We cannot leave 0, 6. We must reduce that to 0. Remember, 0 in the numerator is okay. That's okay. If 0 is in the denominator, let's do this. 0 in, let's remember, 0 in denom, if we have 0 in the denominator, that's not okay. No. No 0 in the denominator. It's okay if it's in the numerator. Here's our first problem with unlike denominators. We would convert that to a fraction, and we get negative 2 over 1 minus 9/7. We do not have like denominators. We have a denominator of 1 and 7. We would find the common multiple. Remember, the easiest way to find a common multiple is by multiplying the two denominators. 1 times 7 is 7. Now that creates a common multiple, and in this case, it creates the least common multiple. Now we need to convert. We need to find an equivalent fraction. Negative 2 over 1 equals how many sevenths? Well, 1 times what equals 7? 1 times 7. In order for it to be equivalent, we need this, what we're multiplying, to be a value of 1, or else it wouldn't be equivalent. Negative 2 times 7 is negative 14. So negative 2 is equivalent to negative 14 sevenths. 9 sevenths is already in sevenths, so the 9 would just continue to stay above the 7. We have like denominators now, which is a nice thing. Once we have like denominators, we can combine their numerators. Negative 14 and negative 9 gives me negative 23 sevenths. No number goes into 23 and 7th, so we can leave it as an improper fraction. That is simplified. Number 22, we again have a whole number that we will convert into a fraction. Negative 2 as a fraction is negative 2 over 1. We have unlike denominators, so we have to find a common denominator, a common multiple. The easiest way to find a common multiple is multiply the two of them. 1 times 8 is 8. So we will have a denominator, a common denominator of 8. Let's find their equivalencies. So we ask the question, 1 times what equals 8? Well, 1 times 8 equals 8. So if we multiply the denominator by 8, we must multiply the numerator by 8 in order to keep it equivalent. That equals negative 16/8. Again, we're already in eighths, so we can bring the 7 over. And now that we have like denominators, we can combine their numerators. Negative 16 and positive 7 gives me negative 9/8, and that is simplified. Number 23, now the next couple of problems will have unlike denominators. And we again have these double signs. So let's simplify the double signs before we find the common denominator. We don't have a common denominator. We have a denominator of 3 and 5. So 3 times 5 is 15. So my common denominator is 15. Let's set up their equivalencies. We're going to write that off to the side. 3 times what equals 15? 3 times 5. So negative 5 times 5 is negative 25. So negative 5/3 is equivalent to negative 25/15. Let's deal with the other fraction. Negative 2/5 equals how many 15ths? 5 times 3 equals 15, so we must multiply the numerator by 3 to get negative 6. Now the negative is already here, so I wouldn't write a double negative because that would make a positive. Remember, we need that to be negative. We like the fact that we have like denominators, let's combine their numerators. Negative 25 and negative 6 makes negative 21/15. Many people would have stopped here. Whoa, I didn't mean to do that. Many students would stop here. Nope, I'm not going to be able to select that. Let's do it this way then. No, I wanted to move this stuff over. Let's move this. Let's move it. Oh, darn it. Come on. Well, let's try one more time. There we go. Let's move. Moving it over. Why doesn't that move? Oh man, that just stinks. All right, the reason why I'm doing that is because negative 21/15, many students would leave this as their final answer. But 3 goes into negative 21 and 15, 3 goes into 21 7 times, and 3 goes into 15 5 times. So this is the answer. You must reduce that fraction. I'm pretty sure that most of you may find that you made a mistake on that problem. Let's look at 24. We got double negatives. Let's rewrite it. 4/3 plus 3/2. Let's find a common denominator. Common denominator is 3 times 2, which is 6. So my common denominator now is 6. Let's convert. Nope, let's find an equivalency. Not really converting. 3 times what is 6? 3 times 2. So we get 8/6. And 3/2 equals how many sixths? Let's multiply by 3. So we get 9. We've got like denominators now. Let's combine their numerators. 8 plus 9 is not negative 17. I got all these negatives all the time. I assume that it's going to be a negative. No, 8 plus 9 is 17. 6, we cannot simplify or reduce that any further. Now we move into multiplication of fractions. We need to remember you do not need common denominators. We don't need common denominators. What we're looking to do is cross-cancel. Remember, cross-canceling well, that was pretty good. I went pretty far with that one pen. Unfortunately, the smart board just became the dumb board. Cross-canceling, we want to find a common factor that goes into a numerator and denominator. So a common factor in the numerator and the denominator. So we look at the numerators and the denominators. 2 doesn't go into 9 or 3. There's no common factor that goes into 2 that goes into 9 or 3. And 4 doesn't have a common factor in 9 and 3. So since there is no cross-canceling possibilities, we're just going to move across numerator times numerator and denominator times denominator. Negative 2 times 4 is negative 8, and 9 times 3 is 27. So I know, because I couldn't cross-cancel in the original fraction, I know that my answer is simplified. I cannot reduce that fraction because there was no ability to cross-cancel. Number 26, we have a whole number times a fraction. We're going to convert the whole number to a fraction, 2/1. And now we see that we have a numerator and a denominator that has a common factor. The 2 and 10, a numerator and a denominator, have a common factor of 2. So 2 goes into 2 once, 2 goes into 10 5 times, and now we've simplified or cross-canceled. Negative 3 has no factor in common. So we are now, that we've simplified it, we're going to multiply across numerator times numerator and denominator times denominator. So 1 times negative 3 is negative 3. 1 times 5 is 5. So my solution is going to be negative 3/5. And we knew it was going to be negative because we had, if we look at the starting problem, 2 times negative 3/10, we have a positive times a negative. So we know that answer is going to be negative. Here we have a negative times a negative, so we know that our answer is going to be positive. We want to cross cancel. Yes, we have a common factor in the numerator and a denominator. 5 goes into 5 once. 5 goes into the denominator 5 once. And we have negative 1 times negative 4. And I'm putting the negative with the negative 1 and the numerator. So we're negative 1 times negative 4. Keep track. Don't put the negative down on the numerator and the denominator. That would mean that there are 2 negatives in each fraction, and that's not the case. Remember, negative signs show direction. So we have negative 1 times negative 4, which is 4. We have 3 times 1, which is 3. A little confusing there. Here we have multiple cross cancelings. We have 2 and 2, which will simplify. 2 goes into 2 once. 2 goes into 2 once. And then we also have 3 and 15. And 3 goes into 3 once. And 3 goes into 15 5 times. We also have that negative sign. Don't forget that negative sign here. Times a positive. So when we multiply across and we multiply the denominators, we have negative 1 times 1, which is negative 1. And we have 1 times 5, which is 5. So my solution is going to be negative 1/5. Division, remember there is no division in fractions, so we have to do a little trick. We have to keep, switch, flip. So we're going to keep the first fraction. We're going to switch from division to multiplication. And then we're going to flip the right fraction and find the reciprocal. So 5/8 stays. Division becomes multiplication, and then 15/8 we're going to flip or take the reciprocal, which equals 8/15. We have a common factor of 8. 8 goes into 8 once. We have a common factor of 5. 5 goes into 5 once. 15 3 times, and that will leave me with 1 times 1 and 1 times 3. We have division, so we have to convert this division to multiplication by keeping the first fraction, negative 1/4. We're going to switch to multiplication, and we're going to flip the reciprocal of the right fraction. Negative 2, remember negative 2 is equivalent to negative 2 over 1, so if we flip that, you get 1 over negative 2. Now, these 4 and negative 2 have a common factor, but they're both in the denominator. Remember, cross-canceling, 1 needs to be in the numerator, 1 needs to be in the denominator. So I have a negative times a negative, and then I have 1 times 1 and 4 times 2, which is 8. A negative times a negative is going to give me a positive. And the last problem, we're going to keep the first fraction. We're going to switch to multiplication, and we're going to flip the fraction. Again, no cross-canceling. There's no common factor in a denominator or a numerator. So we're going to multiply across. Negative 1 times 9 is negative 9. 2 times 2 is 4. And that, my friends, is the pre-assessment. Oh, Mr. Mack almost was done. We have one more. Forgot that one. Sorry about that. We're going to keep, We're going to turn that into a fraction. -1 as a fraction is -1/1. We're going to switch to multiplication, and we're going to flip the right fraction. A negative times a negative is going to give me a positive. 1 times 4 is 4. 1 times 1 is 1. And we can't keep it as 4/1. We must simplify that fraction. Pretty sure that's the last problem. Yes. All right, let me know if you have any questions. Hopefully this little video helped you. Good luck tomorrow.